Jackson Systems is your controls expert in the HVAC industry. With our top-notch technical support and customer service, we make life easier for you, the HVAC contractor. We offer free trainings on any products sold here at Jackson Systems, along with our filter fetch program, free thermostat imprinting, home and business automation with connected sensors, cameras, and even smart stats from Nest, Ecobee, Honeywell, White Rogers, Google, and more. Visit us at jacksonsystems.com to see the products that continue to win industry acclaim among contractors worldwide. Jackson Systems, controls done right.
You're listening to the HVAC After Dark podcast, a proud member of No One's Kiss Ass Network. Welcome to another episode of HVAC After Dark podcast. Well, guys, today I've got Nicholas Rowan in here. He is going to speak about combustion analysis, something that I don't have a whole lot of experience on. Nick has quite a bit of experience on it. Now, I do want to let everybody know that the interview did get cut short. I had some internet issues, but it's okay. It still turned out to be a good interview, and I hope you guys enjoy it. You know, before we get on that, and before we start talking HVAC, I want to touch on a subject that's got me pretty upset right about now. You know, all this bullshit with these NFL players and the national anthem. You know, I don't know if it's got y'all rattled like it's got me, but I think it's just ridiculous. You know, these guys are kneeling down during the national anthem or going to sit on the bench instead of standing up, looking at that flag with their hand over their heart and appreciating this country. You know, where else could they go and make this kind of money? I just don't understand it. You know, I love this country. I love our military. I have friends and family that are military or retired military, and I just think it's bullshit. You know, the President Trump had a thing where he said, you know, wouldn't you like it if one of those owners went out there and said, hey, he wants to sit down for the national anthem? Well, you get that son of a bitch off the field, he's fired. I mean, I agree with that. You know, and you listen to some of the players and they talk about it's their right to free speech and, you know, this and that. It's bullshit. You know, Colin Kaepernick is the one that started all this crap anyway. And it's because of a piece of shit like him that, you know, that the rest of these guys feel like they have to do it too. But, you know, the NFL's taking a big hit. You know, their ratings are down really bad. You know, there's videos floating all over Facebook of people burning their, you know, football attire, you know, their jerseys, their shirts, their hats, and etc. You know, and I'm a huge football fan. I mean, I love football, and I hate, it just doesn't make any sense. There's absolutely no reason for these players to be doing this. It's becoming a little ridiculous in my opinion. But, you know, I guess it is what it is. There's nothing we can do. I mean, I'm still going to watch football, you know. I mean, I love football. I don't know. That's just something that was on my mind that I just kind of pissed me off, so I thought I'd talk about it a little bit. I'd like to hear what you guys think about it too. I've seen how some of you guys feel about it. But anyway, moving on to HVAC. So, you know, here we are. It's the middle of September. It's still holding about 90 degrees here. Still very busy. Had a total of 6 service calls come in today. I didn't get them all done. Well, not all of them are service calls. 2 of them are estimates. Ended up putting the estimates off for tomorrow. Actually going to Ari Michael in the morning. Ari Michael is having a mini split training from Comfort Star. Ari Michael here handles Fujitsu mini splits and Comfort Star mini splits. The Comfort Star people are going to be here putting on a class on how to repair mini splits. So I'm looking forward to going to that class in the morning. I'm actually even going to talk to the Comfort Star guys and see if maybe they'd be interested in coming on the podcast to talk about mini splits and stuff like that. So hopefully we can get one of them to agree to do that. Like I said, this week on this episode, we're talking to Nicholas Nowan about combustion analysis and combustion analyzers. We didn't really touch on the analyzers too much, but I think I'm going to start uploading 2 podcasts a week. I'm not sure. Don't hold me to that. I'm going to try. I may start doing 2 podcasts a week. On the next episode, I'm going to bring back my good friend Gil Cavey from the last episode. And I'm also going to bring in another guy. And we're either going to talk tools or customer service. I posted in the HVAC After Dark group, for some suggestions on topics for the podcast. And one of them was, digital manifolds. Some people asked about, basic hand tools and digital manifolds. And then other people said that they'd really like to hear one on customer service. I think customer service would make a really good podcast. So myself and Gil and another guy are going to talk about, probably going to go with customer service. Should make for a really, really good podcast. A lot of people seemed really interested in that. So I'm looking forward to recording that episode as well. I also want to update you guys that I've been talking to some people, to some tool manufacturers and stuff. We're going to give away the Sporlan Pro R tool later this week. And I've been talking to some other people, and people are going to be sending in some tools and shirts and hats and stuff like that to do in the giveaway. I'm going to try to bring you guys at least 2 giveaways a month. I'm thinking a giveaway every other week. So that's the goal. And also want to take a moment to thank the guys that make this podcast possible, and for their support with the podcast. Right now I have 3 great people on the podcast that support the podcast. That's Jackson Systems, Sporlan, and Bacharach. Those 3 companies have been wonderful, and I can't thank them enough for their support here on the HVAC After Dark podcast. So with that being said, let's get into the interview with Nicholas Nowan. We're talking combustion analysis here. I hope you guys enjoy the episode. Hey guys, John Israel here from the HVAC After Dark podcast and Israel HVAC on YouTube. I'm asked the question all the time, hey John, what's the best refrigerant leak detector out there? Which one should I buy? I always give the same answer, the Bacharach H10. I myself have been using the H10G for the past 5 years and recently started using the H10 Pro from Bacharach. When it comes to refrigerant leak detectors, nothing beats the H10 from Bacharach. For more information, visit mybacharach.com. All right, guys, I'm talking with Nicholas Nowan. I've known Nick for many years now through YouTube. Nick has a YouTube channel, and he's been a follower of mine and many other people's YouTube channel. And I wanted to do this episode on combustion analysis. And I don't have a whole lot of experience with combustion analysis. So that's why I've brought Nick in here. He's got a pretty good bit of experience with it. So we're going to talk to him about how to do it the proper way, and even maybe what he believes is the best combustion analyzer to use if you're doing a lot of combustion analysis. So how are you, Nick?
Good, John. Thanks for having me on. I really appreciate you giving me a microphone to speak on.
Oh, no problem. I thank you for taking time and coming on here.
Yeah, no problem. Anytime, my friend.
Well, why don't you just start off by giving everybody a little background about yourself?
Well, my name's Nicholas Rowan. I work for Rowan Heating and Air Conditioning. It's a family company. My grandfather started it in 1956, I do believe, 56 or 58. And we've just, my grandfather gave it to my parents and my aunt and uncle. And then now it's my brothers and my brothers. It's my brothers and sisters and my turn to take it on.
Right.
We we do a lot of maintenances. We have about 2,000 customers. We do a lot of aero sealing, blower doors, heat pumps, geo, boilers. That's pretty common stuff around here.
Right. And where are you located at?
So we're located right in between Baltimore and DC. We're in the Columbia area. We mainly serve the Washington D.C. area. We have counties here. I guess you have provinces or something like that where you live.
Uh, no, we have parishes.
Parishes. That's it. Yeah, we have counties here. So we have like Howard
Right.
County,
Well,
Montgomery County.
right. We're the only state in America that has parishes.
Yeah, yeah. Don't really get it, but I guess that's cool.
Yeah.
So that's cool. Yeah, so it's mainly, I'm third generation. Been in the business forever. Worked for Rowan my whole life. I've gone through ACCA training. I'm a journey. They call it a journey person now. Was
Right.
journeyman back then. Now it's a journey person.
Right.
And my brother holds our masters for our company, Washington Gas, and he has multiple masters.
So why don't you explain exactly what a combustion analysis is, and why it's so important to have it done on your furnace or boiler?
So, with any gas burning appliance, you should be testing it. We're the professionals. So when we go into someone's house, they're looking to us to make sure that their equipment is running safe. So
Right.
without you testing, you really, if you're not testing, you're guessing.
Right.
So, you can have a furnace that looks like it's burning just fine, and it's not. So,
Right.
and it's just not furnaces. A lot of people, we shouldn't be limiting it to the furnace. So we have water heaters, we have
Right.
cooktop ovens, we have gas fireplaces. There's multiple appliances in the house that are burning gas.
Right.
And we should be checking them, if we're not, who is? So, allowable combustion, parts per million, maximum you should ever see without red tagging a piece of equipment. When a burner, you should never see more than 400 parts per million. Okay.
Right. And that's CO, right?
Yeah, that's CO. That's carbon monoxide. Okay. You have
Okay.
carbon monoxide and carbon dioxide. Carbon
Right.
dioxide is what plants breathe, pretty much, and carbon monoxide is what will kill you.
Right. Right.
So basically, you should, 400 parts per million is extremely, extremely high. A normal burning piece of appliance is going to be down at 10, 20, really never above 100. It's well in our range to get a gas burn appliance below 100 parts per million. Okay.
Right.
So, is it acceptable? Yes. Is it good? Is it good practice to leave that? No. It's dangerous. It's a dangerous burning piece of appliance. You shouldn't have any. Carbon monoxide is a product of incomplete combustion. Okay.
Right.
So anytime you don't have complete combustion, that's when you're going to have carbon monoxide. Okay. So carbon dioxide, where should it be at? Between 6 and 9%. Okay. So when the furnace is burning, you should see between 6 and 9% carbon dioxide and between 6 and 9% oxygen. Okay. So now what this is telling us is how the unit's firing. If you think about it like superheat and subcooling, you're checking basically the refrigerant levels. You're checking how the furnace is burning. Okay. So the more fuel you give it, the more carbon dioxide it's going to have. Okay. So and the less oxygen, because you're burning up more of the oxygen. So if you have a gas burning appliance and you have 4% carbon dioxide and you have 12% oxygen, okay, it's probably underfired. You can turn it up a little bit, and then you'll be burning up more of the oxygen, so your oxygen will come down, from 12% to 11% to 10%, and your carbon dioxide is going to go up. It's going to go from 4% to 6% as you add fuel to it. So as you add fuel, okay. So I guess one thing, tech should not rely off of this one podcast and go out there and say, "Oh, I'm just going to go out and I'm going to adjust every furnace out there." You shouldn't do that. You should definitely be checking everything and making sure it's not burning, spiking your meter, not burning at 1,000 parts per million, But, you definitely want formal training before you get out there and start really tampering with these things. But that's basically really what I look for. Now, you also have, I look for temperature rise in furnace, 40 to 70. You got to look at the nameplate, whatever they want.
Right.
And then, so the flue, the draft, the temperature and the flue. For natural draft, leaving the flue is usually around the flue temperature. So this would be like a water heater or a natural draft gas furnace. Your leaving temperature of your flue should be approximately 270 degrees-ish above your supply temperature. Now, an induced draft, if you have an inducer, it's going to be about 170 degrees above. Okay. Now that's like an 80% furnace. Okay.
Right. Because it's different with 90s.
That's right. It's it's that 80% furnace, that inducer motor basically only pulls a negative pressure in the heat exchanger. It's inducing the draft. It's not creating a draft inside your chimney. So if you go like a foot away from the inducer motor, you're going to have a negative draft. Understand what I'm saying? Even though it's like, it's really just pulling a negative pressure inside your heat exchanger. Now, for condensing furnaces, 90%, it should be equal or greater than the supply temperature. Okay. It should be right around the supply temp. It should be right around there.
I got you.
So you a lot of times you see these things tuned way down, and you don't want to go ahead and crank the gas pressure way high and leave leave it at 5 inches of water column if it's natural gas when it's supposed to be at 3.5 inches of water column. You're going to have to adjust appropriately. That's why I'm saying because you might have to adjust orifices, stuff like that.
Right, because a lot of guys, they go off the gas pressure. They read and most furnaces tell you 3.5 inches of water column. So with a combustion test, how does that come into play? Do you still want to adjust to the 3.5 and then check combustion from there and adjust it if necessary?
Yeah, most definitely. Now, you definitely want to adjust up and down to a percent. You don't want to have 5 inches of water column. So
right.
So I would tune a furnace up to 4 inches of water column, and I'd probably be okay with that without changing orifices. Once you get into changing orifices and stuff like that, it really can get expensive, and you're talking 100th of an inch, less than a thousandth of an inch on those orifices is, a couple thousand BTUs. I mean, it's like such fine tuning at that point. I'll dial it in, get it real close, and know it's burning safe. Really, through this podcast, what I want people to get is it burning safe. Is the appliance, whatever it may be, is it burning safe? We can talk a while for adjusting and tuning it, putting safeties on the flues, temperature switches, spill switches, stuff like that. But really what needs to happen is people need to understand is draft, where draft should be. So if you're checking draft, draft should be around 0.02 in your flue, 0.01, 0.02, maybe 0.03. But you start getting up higher, 0.04, 0.05, 0.06, you're going to start having issues with your appliance. It could be drafting too much. You're moving too much air out your vent. And just the same is if you're not moving enough, you're having drafting issues, and that's when you start building up a lot of, carbon monoxide, and you're going to have issues with drafting. So always right about 0.03 on your draft gauge.
Right. And then you want to keep that CO under 100 parts per million for sure.
Always below 100 parts per million. Now, always below 100 parts per million. If I see a furnace burn at 90 parts per million, there's an issue. There's a major issue. And just like when you see it fire off, if it spikes up, now 90% will spike up a little higher usually than, like an 80%. But if you see it spike up above like 500, 800, 1,000, and then come back down in range, you might need to, start looking at cleaning the burner assembly, your plates, and then I can't stress enough, if people pull this stuff apart and clean it all and then put it back together, and then they don't do a combustion test on it. It doesn't take much to get these things out of alignment and get them burning funky. And by you looking at it, it looks like it's burning great. But, if you're not testing, you're guessing. You got to be testing.
Right. So high CO doesn't necessarily mean a cracked heat exchanger, right?
Nope, not at all. Not at all. It could be a lot of things. High CO. It could be a dirty heat exchanger. It could be It could mean that you're just not drafting good enough. Where it could mean that you could be recycling your exhaust air. It could be coming out your exhaust and going right back in to your combustion chamber. I see a lot of package units, gas package units do this. They have the exhaust right next to the intake on the burner side.
Yeah.
and they just rot out. It just exhausts and it sucks it right back in, and it's just an endless cycle. So I always try to put like a 2 foot piece of round, 3 foot piece of round on it or something to get it away.
Right. So, okay, how can one look at a combustion analyzer and tell if the heat exchanger is cracked?
Okay, the one only true method of checking out a heat exchanger is pulling it apart and looking at it. Okay, but a couple of things I do of checking heat exchangers. One, now it's got to be a really big leak. The way I like checking heat exchangers, if I have one, if you have a big heat crack, you'll have rollout. You'll actually see the flame like coming out. That's a big
right.
Crack. Now, you can have different things happening, and you looking at it doesn't even look cracked. So the way I like checking it is using my manometer and hooking up on my pressure switch, and then waiting for that fan to, putting a T in there, waiting for that fan to come on, and then when that fan comes on, watch your manometer, and it should move. And if it moves when that fan comes on, probably have a leak.
Okay, let me ask you this then. I heard somebody on YouTube, I don't remember who it was. He had a video, and he had a manometer, and he said that if your oxygen on the combustion analyzer jumps up when the blower motor kicks on, then you have a cracked heat exchanger. Is there any truth to that?
Yeah, I guess there could be. Probably have to be a bigger leak. Yeah, I mean, definitely, but I think it'd have to be a bigger leak.
So it would have to be like a big hole or something in the heat exchanger.
Yeah, I mean, you think about it. I mean, those things if they crack, I mean, it would be a very little bit, and your oxygen, I don't know. I have never found one that way. But it may be able to be done that way. I am not going to knock it out. Okay, I have not done it that way. So usually, for most intensive purposes, if there is a minute small crack, and I'm probably going to like a lot of backlash for saying this. Most heat exchangers are on a negative pressure, right? And your furnace is on a positive pressure. So if you have a crack that big where you're seeing something like that, definitely investigate it. But most of the time, I just don't think you're
right.
It's a small crack. That's most of the time you're seeing very small cracks. Which I just don't know if your combustion analyzer can be picking up. It might be. So I don't mean to babble on about that. It might be, but I most of the time, check my CO. Usually get impingement of the flame somewhere, which will give you a spike in CO somewhere.
So if one goes on a furnace and has high CO readings on their combustion analyzer, tell them what they should be looking for to try to correct it. I mean, adjusting the gas pressure, cleaning burners. What should guys be looking for to correct those CO numbers?
If you're overfired, okay, if you have too much gas pressure, you could have high CO. Okay. But so there could be a lot of things that'll give you high CO. Overfired, you're putting too much fuel in there, and it's not getting all burned up. What causes high CO? Incomplete combustion. Okay,
right.
So overfired, that'll show you you'll have high CO. Your oxygen will be low because you're burning it all up. Your flue temperature will be high. Your CO2 will be high. Okay, that's overfired. Underfired. Okay, it'll be the same thing. You'll probably have a high CO. Your oxygen will be high. Your CO2 will be low. So your oxygen will be at like 15, 16. Your CO2 will be at like 4, 3. Your CO, parts per million, will be like 150, 200. So you just just turn it up. So now if you have impingement of the flame somewhere, so say if your heat exchanger is cracked, okay, now your fan is pressurizing that part of the heat exchanger, and it's going to be pushing on that flame, and that flame's probably going to hit the metal, which now you're having impingement of the flame. So now you're going to have incomplete combustion, and now you're going to have high CO there. Okay, everything will look normal. Your oxygen levels between 6 and 9. Your CO2 will be between 6 and 9, but you'll just have high CO. So that, you just start investigating. Not venting properly, high CO. Okay, so if you're not moving enough gas, moving enough air through your chimney, it'll, it won't give it fuel the oxygen. It won't give the flame enough oxygen. So then you won't be burning off all of the fuel, and then you'll have high CO there too. So it's more than just like, what do we do if we have high CO? But things to look for, are your oxygen and your CO2. Where are they? Is my oxygen high? Is it low? Is my CO2 high? Is it low? Where am I burning here? Oxygen, 6 and 9%. CO2, 6 and 9%. If your oxygen's high, your CO2's low, you're under fired. Add gas. And then just the opposite. If it was oxygen low, CO2 high, you're over fired. You really have to use those as your adjustment. You have to, like your superheat and subcooling. You got to look at them. And are they where they should be?
Now that we've covered that, a lot of questions that I get in the Facebook groups and stuff is what analyzer to buy. What is your analyzer of choice?
I have the Testo 327-1. I like it. Black, it's the black and whatever color screen, gray screen, not colored, nothing pretty, but it's quick. You start adjusting the gas, you start adjusting things, and it changes quick. Now, my brother loves the Bacharach.
Right.
Loves the Bacharach. Swears by it. It's tough as nails.
Okay, which one?
Oh, man, I don't know. He's had a couple. 3. He's just a Bacharach guy. It's the older black and white. I couldn't tell you exactly which one it is.
Well, they'll like to hear that. Bacharach is a partner of the podcast, so I'm sure they'll be happy to hear that.
Now, I tell you, they both have their pluses and they both have their minuses. The only problem with Bacharach, it's just a little slower. That's it. Now, I'll tell you, for every one Testo we've had, for every 2 Testo we've had, where one Bacharach we've had, we've gone through 2 Testos. The Testos, sometimes the buttons mess up, the batteries, sometimes they're the rechargeable batteries. When the Bacharach has, I think they're the AAAs or AA's that just get replaced, which is a nice feature.
Yeah.
So definitely, it depends on what you like.
Sporlan, creating products that provide solutions so that your air conditioning and refrigeration needs are not only met, but exceeded. Offer the highest quality products, innovative solutions, and unparalleled support in the market.